Alright, welcome back to day number 3, where now we have our dried silver. Why is it so out of focus? There you can see it a little bit. Little chunks of silver metal. And what we're going to do today is we're going to move on to this simple procedure. We're going to mass the beaker in the silver, record that mass, then we're going to dissolve the silver in 8 milliliters of what's called an 8 molar nitric acid solution. So let's do first thing first here. I'm going to go ahead and get the mass of the beaker and the silver, 82.799 grams. Alright, so this next step, obviously, had to have my goggles on, dealing with an acid here. And so I have my 8 molar nitric acid here. Not hard to see. It's clear liquid. And I'm going to put my 8 milliliters of the nitric acid in here. Seems about good. Now, I do have my window open and a fan on. And actually, after I show this to you, I'm going to quickly move it outside because this is going to be producing nitrogen dioxide gas. You'll see a brown gas come out. Very toxic. Do not want to be anywhere near that for an extended period of time. So I'll show you the reaction. Then I'm going to get it out of here. I'd normally be doing this in a fume hood, but alas, there is no fume hood. Oh yeah. So you can see that brown vapor starting to form. And you see the silver is being consumed by the nitric acid. You also see some blue showing up there, which is the copper, leftover copper. We didn't get all of it, being oxidized. But sooner than later, this is going to be just a clear blue solution once that nitric acid is done with it. So again, just to clear the air, I'm going to go ahead and take this outside. Alright, so I've cleaned up my little work area. I've got my beaker in a covered area outside where hopefully the water will evaporate off. And what happened there was the nitric acid reacted with the silver to form nitrogen dioxide gas. The product we're going to recover is the silver nitrate, so we're taking it back to where we started, essentially, and it's going to produce some water. So the water that the acid was dissolved in, as well as the water that was produced in this reaction, is going to evaporate off, leaving us pure silver nitrate. So what you guys need to do is figure out how much silver was actually formed here, compare that to the amount of silver you should have theoretically formed from your day 2 calculation, and with that you'll be able to calculate your percent yield. Go ahead and then balance the chemical equation for the reaction today with the nitric acid, and then using the amount of silver that we started with today, the actual amount that was in the beaker, based on your calculations, how much silver nitrate should form, what is your theoretical yield, from your stoichiometry of this reaction. So how much silver nitrate are we going to have in that beaker next time? All right, we'll pause here. All right, so welcome back. We are on now day 4. I have dried my silver nitrate, and you'll notice I overheated it just a little bit. Let me see if I can focus that up for you. And you can hopefully see it's a white powder. There is still a little bit of blue in there. I overheated a little bit and caused some of the reduction in the silver in the middle. But that is our silver nitrate we're looking for. So let's go ahead and get the mass of the silver nitrate. So our beaker in silver nitrate is 83.677 grams. Perfect. Now our next step is going to be to dissolve the silver nitrate in a little bit of distilled water. So it's about 20 milliliters. Yeah, I wonder how much air I'm going to have due to the fact I overheated. Did I get it dry enough? This will, guess, figure that out. Alright, so I've dissolved the silver nitrate in about 20 milliliters of water. Now I'm going to add some saturated sodium chloride. And you can see it turned milky white. Maybe you can see there's a little chunky silver chloride being formed in there. Interesting. All right, our next step is we're going to heat the solution and allow it to boil for 5 minutes. So I am going to go ahead and do that right now. All right, so I've let the solution boil, and you'll notice it's now clear, and, well, it's pretty clear. And we have a big blob of the silver chloride that is sitting in the bottom. All right, now we're going to filter that thing off. So my first step now is to grab a slice of filter paper. And to fold filter paper, what we're going to do is we're going to fold it in half. Then we're going to fold that almost in half again to form a little cone. Then when I open up one side of it, I've got this beautiful little cone. We're going to toss that on the balance. The mass of the filter paper is 0.943 grams. Yeah, I couldn't quite fit it on that paper. So now we're going to take a little cone of filter paper. We're going to place it into the funnel. And add just a little bit of water to the side to hold that filter paper down. So just a little squirt to hold the filter paper down. Now this little guy right here is called an Erlenmeyer flask. And I'm going to filter the solution through the filter paper into the Erlenmeyer flask. I'm going to do that using the same technique we used earlier, where I take the stir rod, place it across the top of the beaker, and I'm going to pour the solution through the filter paper. I'm going to do this until all of the solution has been filtered. So I'll go ahead and pause, because this might take a little time to get all this filtered through. Alright, so I've filtered all the solution off and left the silver chloride behind. Now I'm simply going to take the filter paper out, place it in the beaker, and dry this entire unit. That way I'll be able to subtract out the mass of this filter paper and beaker to get the mass of the silver chloride in the bottom. And I'll pause while I do that. Alright, so now I have the silver chloride all dried. A piece of filter paper is inside. And we're going to take the mass of this final system, 85.196 grams. So by subtracting out the mass of the filter paper and the beaker, we should be able to figure out what the mass of silver chloride is for our actual data. We can use our theoretical then to calculate our percent error. And that's it. We are done with that lab other than the work. Thanks, and I'll see you later.